Dear students, today we will learn the formula of diffusion rate with tricks, and we will also learn how to apply this formula. At first, look at the diffusion rate formula. R1 over R2 equals H1 over H2 equals N1 over N2 equals X1 over X2 equals square root d2 over square root d1 equals square root m2 over square root m1 equals t2 over t1. Many students get confused. Will here be 1? No, maybe 2. No, maybe 1. No, maybe 2. To get rid of this problem, we can apply a little tricks here. For this, we have to remember one sentence. That is, Rohan's first ex-girlfriend's name was Dimitri. This sentence is only applicable for numerators. If we can get the numerators and their numbers, then automatically we will get denominators and their numbers respectively. From the name Rohan, we will get three numerators R, H and N. And this X also will be here as another numerator. Here first means 1. So we will write 1, 1, 1 and 1 here. From Dimitri, we will get 3 numerators D, M and T. Here di means 2. So we will write 2, 2 and 2 here. In this way, we have got R1, H1, N1, X1, D2, M2 and T2 for numerator. If we get 1 for numerators, then we will write 2 for denominators. And again, if we get 2 for numerators, then we will write 1 for denominators. All these numerators have 1 here, so we will write 2, 2, 2 and 2 here. Again, all these numerators have 2 here, so we will write 1, 1 and 1 here. Very easy, isn't it? Here R1 equals diffusion rate of gas 1, R2 equals diffusion rate of gas 2, H1 equals distance travelled by gas 1, H2 equals distance travelled by gas 2, N1 equals mole number of the gas 1, N2 equals mole number of the gas 2, X1 equals distance travelled by gas 1, X2 equals distance travelled by gas 2, D1 equals density of the gas 1, D2 equals density of the gas 2, M1 equals molecular mass of gas 1, M2 equals molecular mass of gas 2, T1 equals time travelled by gas 1 and T2 equals time travelled by gas 2. We only can use this formula when H1 equals distance x and H2 equals total distance minus x will be given in a stimulus. Look at the stimulus. This is a cylinder. Its length is 18 centimeter. This is a cotton weighted with XH3 gas, and this cotton is weighted with YH3 gas. XH3 reacts with monobasic acid and produces salt. What is monobasic acid? Here mono stands for one and basic stands for base. So a monobasic acid is an acid that has only one replaceable hydrogen atom. For example, we can say HCl or HNO3 are monobasic acids, as they can donate one hydrogen ion to a base in an acid-base reaction. See, atomic number of X is 5. That means this X is boron, and atomic number of Y is 7. That means this Y is nitrogen. Therefore, XH3 will be boron hydride BH3 and YH3 will be ammonia NH3. Now look at the question number C. Determine the absolute distance where two gas will be combined. We know that gas particles move from a region of high concentration to a lower concentration region. This is called diffusion. That means the two gases mentioned in the stimulus have to cover the distance through the diffusion process. And then these two gases will meet at a certain place. We can use Graham's diffusion formula to solve the math, as the formula is used to compare the difference in diffusion rates between gases. From Graham's diffusion formula, we know that R1 over R2 equals square root M2 over M1. Here R1 equals rate of diffusion for gas 1, R2 equals rate of diffusion for gas 2, M1 equals molar mass of gas 1 and M2 equals molar mass of gas 2. Many students cannot understand which gas will do they consider as gas 1 and which gas will do they consider as gas 2. A little while ago, we have got that this XH3 gas is BH3 and this YH3 gas is NH3. The total distance here is 18 centimeter. In the process of diffusion, this BH3 gas will diffuse at some distance to this direction, and this NH3 gas will diffuse at some distance to this direction. Thus, they will meet together somewhere inside the cylinder. Actually, do we know the distance where they can combine together? No, we don't know. So, we can consider the distance x centimeter for any one gas. If we consider the distance x centimeter for one gas, then the distance of other one must be 18 minus x centimeter. Between the two gases, the gas for which the distance we consider only x centimeter, that gas will be the gas number 1. Therefore, the remaining gas will be the gas number 2. That means gas number 2 will be 18 minus x centimeter. Here, for this stimulus, we will consider BH3 diffuses at x centimeter distance. Therefore, this BH3 will be the gas number 1 and NH3 diffuses at 18 minus x centimeter. Therefore, this NH3 will be the gas number 2. From the formula of diffusion rate, we got R1 over R2 equals x1 over x2. Here, x1 equals x centimeter and x2 equals 18 minus x centimeter. So, we can write R1 over R2 equals x centimeter over 18 minus x centimeter. Now we will determine the value of M1, that means molar mass of gas 1. A little while ago we have considered BH3 as gas 1. Atomic mass of boron is 11. Atomic mass of one hydrogen is 1. Therefore, atomic mass of 3 hydrogen is 1 times 3, that means 3. So, molecular mass of BH3 will be 11 plus 3, that is 14. That means the value of M1 will be 14. Now, we will determine the value of M2. That means molar mass of gas 2. We have also considered NH3 as gas 2. Atomic mass of nitrogen is 14 and atomic mass of 3 hydrogen is 3. So, molecular mass of NH3 will be 14 plus 3, that is 17. So, here we can write 14 instead of M1 and 17 instead of M2. Or x over 18 minus x equals 1.1, or x equals 1.1 times 18 minus x, or x equals 19.8 minus 1.1x, or x plus 1.1x equals 19.8. X is common here, so we can write x into 1 plus 1.1 equals 19.8, or 2.1x equals 19.8, or x equals 19.8 over 2.1. Therefore, x equals 9.43 centimeter. That means here the value of x will be 9.43 centimeter and here the value of x will be 9.43 centimeter. Therefore, 18 minus 9.43 centimeter equals 8.57 centimeter. So, we can say that to meet together, BH3 will have to diffuse at 9.43 centimeter and NH3 will have to diffuse at 8.57 centimeter. The mathematical problem of number C is done. Let's solve the mathematical problem of D. Look at the question. Which concept define acidity and basicity of both compound? Actually, we have to find out whose theory is related here. We can apply Lewis' theory of acid-base here. According to Lewis' theory, we know the compounds that can donate a lone pair of electron are base, and the compounds that can accept a lone pair of electron are acid. See, nitrogen has a lone pair electron. So, nitrogen has the capacity to donate these lone pair electron. Therefore, NH3 is a base. Again, look at the electron configuration of boron at normal state. We do not find any empty orbital from this electron configuration of boron at normal state. But from the electron configuration of boron at excited state, we will get an empty orbital that is capable of accepting that lone pair electron of nitrogen. This is the electron configuration of boron at exciting state. See, this orbital is empty here. So boron has the capacity to accept that lone pair electron in this empty orbital. Therefore, we can say that BH3 is an acid. Look at the reaction. See, BH3 reacts with NH3 and make coordinate bond. This is lone pair electron. This right-sided arrow means coordinate bond, but this left-sided arrow means nitrogen donates a lone pair electron to BH3. Therefore, according to Lewis theory, we can say that NH3 is base and BH3 is acid. And this is the answer for question number D. Thanks a lot for watching this tutorial.